Our group is going to explain the principle of the Stirling engine. So, this is our Stirling engine. First, we will demonstrate the basic concept of this Stirling engine. If we take an empty can and stretch a piece of balloon over the top, like the diaphragm on our engine, the air is sealed inside. Then, we apply the heat to the bottom of the can, and the pressure inside the can will rise and cause the balloon to rise a little. After that, now, if the bottom of the can is cooled by placing it in a dish of cold water, the air inside will cool and the pressure will fall. The balloon will be sucked inwards. So this is the concept, what will make the form of the piston and the key in moving the displacer in our engine.
To get to our diaphragm, which is a simple form of piston. To dry our engine, all we have to do is alternate heat and cold the can, with a heat source at the bottom here of the can and a cool agent on the top of the can, but unfortunately we don't have any cooling agent. This is not a very practical, but the same effect can be achieved by heating one end of the cylinder, the bottom, and the moving air inside alternately from top to bottom. This is the function of the displacer. The displacer takes up space inside the cylinder. When it is at the top, all the air inside is displaced to the bottom, where it is heated and expanded. And when the displacer is at the bottom, the air is moved to the top, which has a cooler surface, and it contracts. As it rises and falls, the air passes around it and it is transferred from the top to bottom. It's the same air that is continually heat and cold. From the engine to work, the top has to be cooler than the bottom. The larger the temperature difference we get, the powerful the engine will be.
Navigation of the crank and the connecting rod allow the displacer to move in the correct relationship to the diaphragm and the flyway. Notice that the displacer will at the top of the cylinder when the piston is at the halfway path. Then the air below is heated up and the air will expand and push the piston up. When the piston reach the top and the flyway momentum will push the piston back to the halfway point. And then the displacer now is at the bottom, and you will see the air is contact with the cold side already, and the air will be contract on the cylinder, then the piston will be pulling down again. Now the piston reaching the top and the flyway momentum will push again to move the piston to the halfway, and then the cycle will begin again and the displacer will at the top again. That's all.
So now, after all of our group mates have discussed and explained what is this Stirling engine is all about, but we have a problem with our Stirling engine. Our engine would not function as it was meant to be, and now we have to find out what are the reasons. The first problem that we identified was a construction problem. The needle attached to the displacer was not upright, or should we say 90 degrees straight. This caused the displacer to collide with the wall of the engine, thus producing friction, and the friction is large enough to enable the engine to stop function. The second problem was a pressure leak. The needle connecting to the displacer and the rods through a hole on top of the can. The hole is here. The hole is too big, thus allowing the hot air that are inside the engine to escape through the hole, thus causing a pressure leak. Thank you. In the end, this is our group mates, and we are from group 3B, and this is our Stirling engine, and so thank you.